How does NumPy vectorization speed up slow Python loops? Imagine trying to count grains of sand on a beach one by one. It would take forever, right? Now picture using a giant scoop to grab thousands of grains at once. That's similar to what NumPy vectorization does for Python loops. When you write a loop in Python to perform calculations on each item in a list or array, Python has to interpret each step. This interpretation adds a lot of extra time, especially with large datasets. For example, if you want to square 1,000,000 numbers using a Python loop, it takes quite a bit of time because Python has to run that loop over and over again, executing each instruction separately. NumPy, a powerful library for data analysis in Python, handles arrays differently. Instead of looping through each element, it uses a method called vectorization. This means it applies operations to entire arrays at once, using code written in a language called C, which is much faster than Python. Think of it like giving one command that affects all elements simultaneously, rather than giving a command for each element individually. For example, if you want to calculate the expression squared plus 3 times x plus 1 for 1,000,000 numbers, doing it with a Python loop might take around 0.46 seconds. But with NumPy vectorization, it only takes about 0.8 seconds. That's more than 50 times faster. This speed boost is because NumPy uses optimized, low-level code that runs directly on the CPU, reducing the overhead of interpreting each instruction. The main reasons this works so well are that vectorized operations skip the repeated interpretation of Python code, and they run in compiled C code that is much faster. Also, NumPy arrays are stored in contiguous blocks of memory, which helps the computer access data quickly. This makes processing large datasets much more efficient and practical. However, it's important to remember that vectorization works best when the operation can be expressed as a single, bulk array operation. If your calculations involve complex logic or steps that aren't supported by NumPy, then you might still need to use Python loops, which are slower. But for most numerical tasks involving arrays, vectorization is a game changer. In simple terms, NumPy vectorization speeds up slow Python loops by shifting the work from slow interpreted Python code to fast, compiled array operations. This makes handling large amounts of data quicker and easier, especially in data analysis and scientific computing.